So can you see my screen?
Yes, sir.
Yes, sir.
Okay. So we will continue on the language of relations and functions. So this will be still on the module 3. I will be uploading the files or the presentation on the Canvas later. So the language of relations and functions. First, our topic here is the empty set or null set. So yesterday, could you still remember? Hello?
Yes, sir.
Could you still remember the type of set that we tackled yesterday?
Yes, sir.
And what are those set?
Proper set, sir.
Proper set and
Subset, sir.
yes. Today we will be continuing on the different set, the other set that will be included here in this module. So the first one is the empty set or null set. Uh, it is a set which does not contain any element, is called an empty set or the null set or the void set, and it is denoted by this symbol. This symbol is called phi or phi, and it is read as phi or phi. Um, in rooster form, phi is denoted by this curly bracket. So do you remember, guys, yesterday we have an example which we are looking for the elements, but the answer is only the curly bracket.
Yes, sir.
Yeah, that is an
Yes, sir.
empty set. That is an example of an empty set. It's still a set, but it doesn't contain an element. So it is an empty set or null set. An empty set is a finite set. Since the number of elements in an empty set is finite or finite, for example, is 0. This 0 means nothing, not the whole number 0 or the 0 number. Gets? So, for example, the set of whole number less than 0, is it an empty set or no?
No, sir.
Yes, it is an empty set because if you remember yesterday, whole numbers are from 0 to positive infinity, right? So the set of whole number less than 0, it's nothing, right? We don't have -1, -2, because whole numbers will start from 0 and then to positive infinity. So if they are going to ask you what are the set of whole numbers less than 0, it's nothing, right? It's empty. Did you get it?
Yes.
Yes, sir.
Gets? So another example will be, clearly there is no whole number less than 0. Therefore, it is an empty set. So another example is this. Let set A be x, wherein x is less than 2 and x, I mean, wherein x2 is less than x and x is less than 3. And x is a natural number. Here, the set A is an empty set because there is no natural number between 2 and 3. So if you will remember again yesterday, we talked about natural numbers. It will be starting from 1 and then to positive infinity, right? So what natural number or whole number is in between 2 and 3? Nothing, right? we don't have a natural number in between 2 and 3.
Yes, sir.
So it would be considered in an empty set or a null set. Next example would be set B. Set B is a set wherein x is a composite number less than 4. So guys, what is a composite number? A composite number is a positive integer that can be formed by multiplying two smaller positive integers. Equivalently, it is a positive integer that has at least one divisor other than 1 and itself. So, guys, can you tell me what is the smallest composite number? Did you understand what is a composite number? Guys, let's use the mic para so that we would be faster and then we can end the class earlier. Let's be active.
4, sir.
Yes, the smallest composite number is 4. How does it become a composite number? A composite number, you would know that it is a composite number if you could divide it by another number rather than 1 and itself. For example, 4. 4 could be divided by 4, right? 4 divided by 4 is 1. And 4 divided by 1 is 4. So, for this, the requirement for it to be a composite number is that you could divide it by 1 and itself and at least another number. So what number could you divide could you divide the 4?
Sir, 2.
Yes, that's right. So it is the smallest composite number. Gets? Did you get it? What is composite number?
Yes, sir.
So
Yes, sir.
a composite number is a number that you could divide it by 1 and itself and another number and another number. Okay. So in this example, set B, let's find for the element x where x is a composite number less than 4. So since 4 is the smallest composite number, we won't have another number that will be available here in this set. So set B is an empty set because there's no composite number less than 4. Gets? So that is how we look for an empty set. And this one, phi or phi is not equal to the set that contains 0. This is what I'm telling you earlier. Because this is a set which has an element 0. Gets?
Yes, sir.
Yeah, because 0 is part of the whole numbers, right? If you would remember the real number system yesterday, I think also 0 is part of the integers. Gets?
Yes, sir.
Yes, sir.
It would be an empty set or null set if it is really nothing inside the set. Not 0, it's nothing. So the cardinal number of an empty set is 0 or nothing. Cardinal number. We will talk about this later. Cardinal numbers. So let's move. There's no question on empty set?
Yes, sir.
Okay, so let's move to singleton set. A set which contains only one element is called a singleton set. For example, set A, wherein X is neither prime nor composite. So what is a prime number? A prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. A natural number greater than 1 that is not prime is called a composite number. For example, 5 is a prime because the only way of writing it is a product 1 times 5 or 5 times 1. Involves 5 itself. So, do you get what a prime number is?
Yes, sir.
Yes, sir.
So, what is our smallest prime number?
2, sir.
Yes, right. 2. Because prime number is a whole number greater than 1 and whose only factors are 1 and itself. Yes? So, for this, set A, wherein X is neither prime nor composite, it is a singleton set containing one element because the answer here is 1. 1 is not a prime number and not a composite number, right?
Yes, sir.
Okay, so for set B, wherein we're going to find for X is a whole number and X is less than 1. So again, yesterday or earlier, we talked about 0 as a whole number, right?
Yes,
Yes,
sir.
sir.
So the element that will be contained here is the whole number 0. So only one element. For the next example, let set A be X, wherein X is an element of the natural number and X squared is equals to 4. So here, A is a singleton set because there is only one element, 2, whose square is 4. So if we will square the number 2, it would be equal to 4, right? So the only element inside here in this set is the element 2. Gets?
Yes,
Yes, sir.
Okay, so next would be this set wherein X is an even prime number. Even prime number. So the only even prime number is 2. Most of the prime numbers are odd. So here, B is a singleton set because there is only one prime number which is even. And that is the number 2. So are there any questions for the singleton set?
None, sir.
So let's move to finite set or finite set. A set which contains a definite number of elements is called a finite set. Empty set is also called a finite set. For example, the set of all colors in the rainbow. So, how many colors are there in our rainbow?
Sir, 7.
Yes, that's right. Red, orange, yellow, green, blue, indigo, and violet. Do you guys have a subject circuits 1? Or wala pa kayong circuits 1?
Wala pa, sir.
Wala pa, sir.
Okay. There you would encounter the resistor color coding, which is similar to the rainbow color. So for this, let's move on with the finite set. The set of all colors in the rainbow is 7. So it is finite. May bilang. It has a finite number of elements. So for this set n, wherein x is an element of n, and x is less than 7. So what do you think are the elements for this set?
Sir, 0 to 0, 1, 2, 3, 4, 5, 6, sir.
Remember that natural numbers will start from 1. Whole numbers will start from 0. So for this, the elements inside this is 1, 2, 3, 4, 5, 6. Gets?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So for the next set P, the elements inside is available already here. It's from 2, 3, 5, 7, 11, 13, 17, 19, 21, and so on until it reaches the number 97. So that's how we define a finite set or finite set. Questions?
None, sir.
So let's move. How about the infinite set? The set whose elements cannot be listed. Set containing never-ending elements is called an infinite set. Set of an example here is a set of all points in a plane. So, for example, I draw a line like this. Could you tell me how many points is available here?
Infinite set.
Yeah. So, what more if I draw a rectangle? So, a plain rectangle. So, we cannot count how many points is this. Gets?
Yes, sir.
So, for our other example, set A, wherein x is an element of n and x is greater than 1. So, it would be from 2 to positive infinity. Right? Another
Yes, sir.
example is the set of all prime numbers. So what is again a prime number? It would start from 2, 3, 5, 7 until we reach the positive infinity numbers. So note, all infinite sets cannot be expressed in rooster form. You remember this, right? Infinite sets cannot be expressed in rooster form. So let's move for the cardinal number of sets. So earlier we have a slide wherein we talk about the cardinal number of set for the null set, right? The void set. So the number of distinct element in a given set A is called the cardinal number of A. It is denoted by this n, close and open parentheses, and the set. For example, set A wherein x is an element of n and x is less than 5. Remember that this n is natural number. So how many elements are there in this set? It would be 1, 2, 3, 4. So the cardinal number of set for this set A is 4. Gets?
Yes,
Yes,
sir.
sir.
So for set B is set of letters in the word algebra. But here, the definition of cardinal set says that the number of distinct elements. So if we would count the distinct number of elements here, it would be 1, 2, 3, 4, 5, 6. Is this A included?
Oh, sir.
D, sir,
Yeah.
kasi
Yeah. If we will look at the dictionary, distinct generally means different, right? But for set, in set, no two elements should be the same. That's how we define distinct in set. There should be no two elements. So the elements in this set is A, L, G, E, B, R. And the cardinal number of set for set B is 6. Gets?
Yes, sir.
Yes, sir.
So what is the cardinal number of set for void set?
None, sir.
Hindi siya none. Zero siya, zero. Wala. Gets?
Yes, sir.
So next would be the equivalent set. Two sets, A and B, are said to be equivalent if their cardinal number is the same. The symbol for denoting an equivalent is this symbol. So for example, set A is equals to 1, 2, and 3, set with an element 1, 2, and 3. Here, the cardinal number of set is 3. And for set B, the element is P, Q, R, and the cardinal number of set is 3. Therefore, A is equivalent to B. Gets?